Recording.
Hello everyone. In today's lesson, we are going to talk about a new topic, which is surds. So first of all, we will try to understand what is the meaning of surds. Surds is basically related to the square root numbers. So when we take the square root of a number, let's say square root of 2, square root of 3, square root of 4, square root of 5, if when I solve them using a calculator, if I find the value of square root of 2, it is going to be 1.414 dot dot dot. It keeps going. Same way, if I calculate the square root of square root of 3, so it is going to be 1.732 dot dot. It keeps going on. Square root of 4 is 2. Square root of 5, it's 2.236 and so on. If I take square root of decimal number, let's say 6.25, so it is going to be 2.5. So what I see here, I could see there are two numbers, square root of 4, the 4, and square root of 6.2. These two square roots, when I'm taking, I am getting a whole number or I am getting a rational number 2.5. I can write it like 2.5 as 25 over 10. I can write it 5 over 2. Meaning, if we divide this number, I can write it in a decimal number. It's a terminating number. So, if you take the square root of numbers and you are getting either a whole number or a rational number, meaning a number which is terminating, a rational number, so we call that those are the simple numbers, and the other numbers which do not show this behavior, those are known as surds. Meaning the surds are the square root of those numbers which are not the whole numbers or which are not the rational numbers. Okay, so either they should be a whole number or a rational number, then they are the normal numbers. Otherwise, their square roots, we will call them as the surd. So square root 2, it is a surd. Square root 3, it is a surd. Square root of 5 is a surd. Square root of 7 is a surd. Now, if I check a number, let's say square root of 16. Square root of 16 is 4. So it is just a normal whole number. So this is not a surd. So the first thing we need to understand the meaning of surds, and I hope it is clear. Now, whenever we learn about the surds, like operations on surds, we can do addition, we can do subtraction. All these operations we can apply on surds: addition, subtraction, multiplication, division of surds. And the most important in all of these we need to learn is the simplification. How to simplify a surd. Sometimes if I am given a surd, let's say square root of 8, I can write it in a simplified form. For example, if I have a number 2 plus 2, rather than writing it 2 plus 2, I would prefer to write it like a 4. Same way, if I have a surd like square root 8, we have to check can we simplify it? If we can, we have to always simplify. The process is really simple. We can understand it in two ways. What we can do here is, let's say I have to make this square root 8 in the most simplified form. What I do, first method is factor tree. And the second method is, it's based on how much you are familiar with the square root of the numbers. So we know the numbers like square root of 1 is 1, then we have squared number as 4, then we have a squared number 9, 16, 25, then we have 36, then square number is 49, then square number is 64, 81, and 100. I write the squared numbers from 1 to 100. Now square root of 8. For what I will do, I will see this 8 can be written as a multiple of any of these. So I choose that 4. I can choose 4 because 8 can be written as 4 multiplied by 2. So square root of 8 will be equal to square root of 4 times 2. And this can be written as square root of 4 times square root of 2. I splitted this square root sign with the both numbers in multiplication. You can do only it in multiplication. You cannot do it on the other. Like if it is 4 plus 2 square root, then we cannot write it like square root of 2 plus this. This is not allowed. Okay, only in multiplication division we can write the square root sign separately. So now we know square root of 4 is 2 times square root of 2. So the answer is 2 square root of 2. So square root 8 can be written in a simplified form as 2 square root of 2. This would be used in addition and addition and subtraction of the surds. Okay. Now let's take the same example and let's say we have to do it with the help of a factor tree. So what we can do, we write the number 8 and then I will try to write it as a product of two of its factors. So let's say it is written as 4 times 2. Now 2 is a prime number, so I'll stop here. But 4 is not a prime number, so I can go further. So it is 2 times 2. Now I got all the numbers and the lead points, like the end points as prime numbers. So I can say 8 is equals to 2 times 2 times 2. And similarly, so square root 8 will be square root of 2 times 2 times 2. And now start forming the pairs of 2, 2. So here I can see there are two 2's existing together. So I can write it 2 square times 2 and square root. And now split the square multiplication square root sign. So this is this one, multiply by square root of 2. Always remember, if you have written any number like this way, square root of a square, so square and square root sign always get cancelled. This should be a whole square. It should not be like this way, 2 square plus 6 square and square root. You cannot write it like, okay, this is 2 square or this is just 2 plus 6. This one you cannot write. This is not equal. Remember, only one number it should be here or the number should be in multiplication. So I can conclude from here that this square root sign and this square root, the squared sign, they will be cancelled out. So what we left here is 2 from here and then square root of 2. Okay, let's take one more example. For example, I have a number 32. I have to find its square root. I have to make it in the simplified form. So first thing is, again, I will check my squared numbers. And even if I write up to here, I can see that 32 can be written as 16 times 2. So I write 32 square root is equals to square root of 16 times 2. And then I split it as 16 square root times square root of 2. 16 square root, it is a perfect square, so it is 4 and square root of 2. So this is the simplified form. If I do the same question with the factor tree, so I will write 32 as, let's say, 8 times 4. Then this 4 can be written as 2 times 2. Now we got prime number, so this process will end here. Now we look for 8, so it is 2 times 4. This 2 are the prime number, these all. Next is 2 times 2. So I can see that 32 square root can be written as 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Now forming the pairs of 2's. So I have 2 squared times 2 squared times 2. And now because there is a multiplication, I can split it. So square root of 2 squared, square root of 2 squared times square root of 2. Square root and square signs would be cancelled. So 2 times 2, which is 4, multiplied by square root of 2. So this way you can simplify the surds. Let's take one more example. And that example is, let's say we have 75 square root. So first method I will apply is just the taking the help from the squared numbers. So 1, 4, 9, 16, 25, 36, and so on. Square root of 75, I can see it's a 75 is a multiple of 25. So I can directly write 75 square root is 25 times 3 square root of 75. Then I will split it up as square root of 25 times square root of 3, which means it is 5 square root of 3. So this is the simplified form of writing 75 square root. Other way is, I can try to generate a factor tree for this square 75. So I know 75 is 25 times 3. 3 is a prime number. 25 can be written as further 5 times 5. So basically 75 is 5 times 5 times 3 and its square root will be like this. Now forming the pairs of 2. So it is 5 squared times 3, the whole square root. And then I split it up into 5 square root and square root of 3. Square and square root sign get cancelled. So we got it 5 root 3. This way we can simplify even the big square root numbers, even the big square root surds. Surds only, not square root surds, surds. And let's take one more example. And if you do not get like, okay, which number we should multiply, so you can stop there only. Let's say we have a number 108. You should be very good with the tables if you want to apply the first method where we do the numbers like 1, 4, 9, like those numbers. 1, 4, 9. Then we have 16. Then we have 25, 36. And then we have 49, 64, and so on. Now this 108, this can be written in a different forms. So because these tables, you should, if you know the tables, you can see that 108 can be written as 36 times 3. So square root of 108 will be square root of 36 times 3. Then it will be square root of 36 times square root of 3. And we know square root of 36 is 6. So it will be 6 root 3. And another way is you can write it as the like the factor tree. You can generate a factor tree for this number and then you can solve it. So 108, if I try to write it, so I can start with 2, it is 54 here. Then I can write it like 2, 27, 3 times 9 and 3 times 3. I got all the prime numbers in the end. So now I can write 108 is equals to 2 times 2 times 3 times 3 times 3. And square root of this will be equal to square root here. Now form the pairs of 2's. So this is one and this is another. So it is 2 squared times 3 squared times 1 3 more. So this will be 2 squared square root times 3 squared square root times square root of 3. Square root cancel, square root cancel. So we got it like 2 times 3 times square root of 3, which is 6 square root of 3. So this would be the answer. Okay, so this was all about the simplification process. Thank you.